Seconds early, so that everything kind of warm up, Twitch stream do its thing. And trying to get a little bit better at streaming overall, so I think the extra few seconds up front allows some time to edit, right? So I can kind of trim down the video as opposed to the first few seconds running around and being frantic. Oh, looks like you can't hear me. Interesting. Chat, and someone just can't hear you. Better? So I play around with all these tab suspension things and all of that, and I never know. I use like one tab, I use a few other things, and I found myself in this nebulous place. Yeah, I found myself in this nebulous place where I'm in a pickle now. Like, I've got so many of these automatic tab suspenders going in different browsers, I never know actually what's suspended and what's not. That's on me. Alright. Some other shows may want to restart stream so you can upload after yeah, exactly. So you guys couldn't hear me like I was saying. Like, hopefully starting a few seconds earlier kind of helps me to have a little bit of edit wiggle room. So that being said, this week on Storybox we're going working on the state pattern, which, let's go over to the wiki, get a good definition of what that is. I'll get into this musing section here in a second. I'm actually might be doing too much with this wiki space, but I want it to stand on its own 2 feet. Alright, so the state pattern is, by definition, to allow an object to alter its behavior when its internal state changes. The object will appear to change its class. This definition is not helpful. And I mean, it is helpful, but I'll tell you what happened to me the first time I came across the state pattern. I read it, I learned it, and I was just going in order, right? And so then I got to the strategy pattern, and I went to go implement it. And you find this with a few of the kind of the base patterns, is it's hard to distinguish one from the other when you go to implement. The definitions are in fact different, the UMLs are in fact different, but you go to implement the patterns, and you start asking yourself, well, okay, in practice, these seem very similar. So the musings come in. I'm just going to read it. The state pattern is very similar to the strategy pattern. Where they differ is that the state pattern, when changed, should give the appearance that the context itself has changed classes. For example, a video game has a menu state and a playing state. However, the input device is the same. Does that make sense? So, and I'll freelance the rest of it. So when you have the same controller input, but when you start up a game and the game is in the state of menu, the inputs are select, back, start, whatever have you. That's very different from the state of actually being inside the game and controlling the character. So even though you're going through the same interface, the cord's going right to the same machine, the game changing its state gives the appearance of a complete context switch, which is what we want from the state pattern. Whereas the strategy pattern is is implemented for, let's just say, you're inside of Super Mario World, and you have the jump button, and the behavior of the A button is to jump, right? And then you go to a water world and you're swimming. Well, now you want a different strategy for that same behavior. You still want to hop up a bit inside of the water, but the strategy changes. The state of the game is still playing, right? But the strategy for that context alters a bit. So I hope I explained them all right. And I'll leave the musings here to read. But the state pattern is great for a lot of reasons. Chief among them is, and you'll see this in different contexts implemented in .NET, but changing states can be a very expensive process. And you don't want to load up or lose any more than you have to at any given time. A great example is if you take your computer and you go into a standby state, right? Or a suspended state. A variety of things have to happen. Things get shut down, things change internal strategies, and you get a very limited scope as to what the computer is going to respond to. And then when you resume, that time it takes, this expensive cost of resuming, because you're loading all these things that you now need. So when we change state, we want to be very deliberate, and we want to take advantage of being able to only have the operation be as expensive as we need it to be. We don't need to load up anything unnecessarily, because again, what we're doing could be in and of itself a pretty costly activity. Okay, so I think that we have a long enough rant about what the state pattern is, but how does that help us in our game, or the beginning framework of our game? So we've got this issue where we have an interpreter, which we covered last week. So wait, hang on, was it last week? Woo, 2 weeks ago. So we've got this interpreter pattern that lives inside of the context, and it's wildly different depending on what state the game is in. But we have no way to tell it what state the game is in. So we're very dumbly, is dumbly a word? We're very inefficiently and procedurally and scripty in our methods of changing this. So only we know why and for what reason we change from one interpreter to the other. But once we move from the player state into the game selection state, the entire mechanism of input, display, interpret, process, everything should change. Once you're selecting a game, nothing about that should care about your player name, right? Same thing with inputting a command. Once we're this deep in the rabbit hole, we certainly don't need any of the resources or the logic associated with assigning the player name or selecting the game. And depending on how complicated our loader gets, we definitely don't want to have all that extra cruft following us around. So what we really want to be able to do is to kind of bake some intelligence into our game and allow it, upon processing an input, to go ahead and handle its own state. So let's go back over to the UML. So, pretty basic, and also, again, not very helpful. We've got a context object, which we just did the context object pattern last week. So we've got one to work with, which is going to be our game context. And then we're going to have a state, right? So we're going to have a state contained within our context. And this code is never really helpful. But you can see some basic architecture, right? In terms of the state, as an abstract class, again, we're always dealing with this, this abstraction. So we're taking our problem and we're decoupling it from our implementation so we can kind of look at it and really explore it. Nothing too crazy here, but here's our context. And we have our state, which again is that abstract class. And on construction of our context, we're setting the state. Let's come look over here. Let's go ahead and throw a new class into our common library, into our game domain. I'm just going to call it game state. We're going to make this a public abstract class. This will be our game state. Doesn't need to be anything in there right now. Ooh, and I get to check chat in 1 minute. It's my cookie. Checking chat's my cookie. All right, so come back over into our game context. We now have a new property that we want to throw in here. There's going to be public game state. Let's call it game state. I'm going to getter and a setter. Okay. Ooh, and style cop on my other PC loves to throw those using statements inside of the namespace. I'm going to go and correct that. Cool. Little tiny refactoring. Oop, and let you guys digest all that ranty stuff while I check chat. So I saw Smudge, but hey Stu, good to see you. Hey Dan G. Ooh, and a Mystical Puka. All the regulars are here, and a newcomer, Ubi. Good to see you. So I'm just going to start with the end one. It says, I keep forgetting how lazy C# is. Interesting. Okay. I guess C# is lazy. I think he means lazy in the sense that you got to think less about what you're doing. Like a lot of the lower level stuff's being taken care of for you, which honestly isn't an artifact of C#, it's an artifact of .NET. So you will get that criticism sometimes. And because you aren't handling pointers and all of your code is very nicely managed for you. Garbage collection, by and large, something you don't have to think about, right? But again, those are all artifacts of the .NET framework, and not necessarily C#. So anything that you write on top of the .NET framework is going to give you the same benefits. All right, so here is our game state property. And if we go just by this, we've got our constructor, and we're just going to go into the same thing here, because we definitely want a default state to be set. So I'm going to say public game context. And if we do, and I'm doing regions, so I'll just go ahead and do another one for constructors. So this is where I'm going to set my game state. I haven't implemented one yet, but I definitely want to, if someone just snooze up the game context with no parameters, because I doubt we'll have any, we want to have a default state that's set. Let's go ahead and start writing some of our stuff. Sorry, my keyboard went a little weird there for a second. I don't know if you've ever felt this. It's like when one of your little, I have a Dell keyboard, so like you've got these little feet on it, but they're retractable, and sometimes one retracts and then one doesn't, and it starts like a wobbly table situation. End rant. Alright, so where was I? Alright, so up until now I haven't had a game folder inside of my core. So let's go ahead and add one. Add a new folder. Game. My core. And this is where I'm going to put the concrete implementations of my game state. So I'm going to go ahead and add a new item. And we're going to make this load player state. Seems fair? that's going to extend, oops, not game context, game state. So far, so good. So now if I come back over to my game context, and again, the beauty of architecting at a high level is I don't need to really worry about any of the particulars right now. So I can keep coding very, very sparsely and just kind of get my brain around the issue at hand. So if I say game state is equal to new load player state. So this is so far matching the architecture that we got from the example. I'm just setting the state. Now they used a private backing field for their property, and they're putting the algorithm, or an algorithm, inside of the setter, which I think is fine, but you really got to think that through. You really got to decide how much logic do I want to put in my setter. We're not quite going to do that yet because we're still building some stuff out. But, alright, so let's go back, back over to this guy. And inside of their state, they've got just one abstract method called handle. Let's borrow that, and then if we want to change it, we're free to do so. Alright, so inside my game state, I'm free to change this contract. Oops. I don't care what that context is. Alright. So now by adding in this abstract method, I'm saying that everything that implements game state has to have a handle method. Well, I don't quite want that yet. What I do want is interpret. So what's going to be happening is I want the state to control what interpreter it uses. Which means that I also want the game state to have a private expression called interpreter. Oops. Oh, it already put it out for me. Hang on. It's too smart for its own good. Okay, so, and I want this to be the case because I want these guys to be their own little self-contained things. So when I say, like, let's just say protected game state, that takes in an expression called the interpreter. And then I wanted to set the internal interpreter is equal to the interpreter. That gets passed in. Cool? So, this would need to be handled by the implementing class. But, depending on how we end up doing this, we might not need to. Before we jump around too much. So, coming over to player state, it's crying at me because I did not implement the missing members. Which are both of those. Alright, so I used ReSharper to help me implement these things. Now, player state, I already know what interpreter I want to use. So I don't need to take that parameter in my constructor. I can just pass it into my base class as new player interpreter. So I'm not doing anything crazy inside of this method right now. I reasonably could. I could say that the way that my my player state handles an interpretation is a little bit different than any other state, right? So right now we don't really need this. Let's go back over to the example that's given. So they've got a handle command here because inside of their states, they're ensuring that when a request comes in, they're asking the state to handle it. I'm sorry, inside their context, which is fine, but it's actually too simple for our needs. And this example is going to break down as soon as it comes across any real example. So this is exactly where we're going to start diverging. I'm not going to go into exactly why this is limiting. Hopefully you'll see that because we don't have, we got like 25 minutes left, I think. But, anywho, I will go into it. So, their example definitely demonstrates how the behavior can be swapped out. But the implementation they choose is kind of form-fitting, right? Like, well, you don't always want to use request. You might not always want to use handle. And if we follow this to the T, it's not going to really make much sense inside of our context. Stu says 1 hour and 25 minutes left. If only. If only. Okay, so this is going to segue nicely into our chain of responsibility and then also our facade patterns as we go to refactor and clean things up. But if we come back over to our game state, we do see that we are setting an interpreter that comes in. We're passing that to our base class in our load player state. So it's something that the calling layer has to be aware of. So if we come back over to our game context, I don't have to pass it in anything. By the very nature of it being a player state, it knows that the interpreter that it's going to use is going to be the player interpreter. Which is good, because that's what I want our architecture to do. We want our architecture to where it makes sense to fold, right? We want it to be intuitive. And so if you don't have to explicitly declare everything that you want to do at every level, then you benefit, because that implicitness lends itself to intuition. I felt too whimsically philosophical. So, if I'm in a load player state, the more that I can infer about that state and assume to be true, the better off I'll be when it comes to actually implementing it. So, let's go ahead and create, first, let's just tackle one last time this guy. So, we can probably, for right now, make this take in the game context, or iGame context, and then we'll have a place where we can put in whatever we're doing other places as far as interpretation. Let's see if it fits there. Or do we need to keep it abstract? So come back over to the program, and everything's mad. Okay. So, we read in the user input, we load the interpreter, and then we interpret. So if we go here, into the player interpreter. Alright, so the interpretation is within the interpreter itself. So we come back over to our game state. Inside of our underscore interpreter dot interpret, we pass in the context. So in theory, this is all we need to do. And we covered reference and value a little bit, and we're a little bit further down the rabbit hole. Hang on, I'm going to check chat, because I've seen out of the corner of my eye my name pop up a few times. So much fun in chat. I need to check out Stu's. I'm not sorry. I need to check out Smudge and Stu. Put Smudge's name first because his ugly mug is the one on the camera. But when those guys stream, that I can actually join the audience and get in on the fun of the chat. There's so much good stuff being passed back and forth. Okay. So, alright, right back in it. Let's go ahead and clean up a little bit. I already feel bad. I'm sorry. I'm sorry, Smudge. I didn't mean to say your ugly mug. It's a lovely mug. So, we aren't doing very much here, right? We're calling the interpreter, we're passing the context. So because we're passing in our context, whatever changes that are made inside of interpreter are going to persist inside of our application domain. So that we don't need to do any kind of funky assignments. Like we don't need to say like, oh, context is equal to context blah blah blah. We can stay concise and clean. So the only problem we run into is while the interpretation handles is happening here, which is great, we don't actually have a way to tell what state the game is in. I could tell you what type of interpreter is being used, right? So I could say, just come down to this little space right here. I could say var type of interpret is equal to type of context oops. And I could do some tests and some funky things, and I could do a bunch of stuff, and I'd figure it out, right? But all I really want to be able to do is do something along the lines of context.state. That's all I really want to do. So how do we do that? Let's come back over here into our game and add a new item. And it'll be a class just for right now. And we'll say game state type. Make that an enum. We'll say load player, game selection, and then also claim, I guess. All right. So, and so while it didn't seem like before that we needed to have every interpreter implement this interpret class, this interpret method, we kind of do because we want to put the onus on that implementation, that content implementation, to also tell us, well, could you also change the state? That would be awesome. So let's jump around just a little bit, come back over into our game context. So we also have a game state, but we also want to have a public game state type. Cool. So this way, when we're out here in the program and we want to say context.GameStateType, it's going to be equal to one of these three. So now we can do some really smart checking on what the state of application is in. That being said, we need, inside of our interpreter, let's go ahead and back this up. Alright, so we need to make this abstract. And then instead of our load player state, we also want to ask for the context. And when this guy comes in, oops, let me go ahead and fix this. And so when this guy comes in, we want to say the context dot, hold on, so many mistakes. Inside of this guy, we're also going to need to add the game state as a property. Oops. And also the game state type. Man, where's my typing? My brain's like a few seconds behind my fingers. Okay. So, we're going to introduce a problem here that we're going to fix inside of our chain of responsibility pattern. But for the time being, we want to just do that. Oh, hang on. I think I'm behind in my ability to read chat, but let's catch up. Smudge says enums are nice and all, but not extensible. Very true. And so in Smudge's advanced stream, you should be thanking me because I give you all these fun things that only your advanced stream can solve. Which is a great plug for Smudge's advanced stream and the things that he covers. There's only so far that these patterns can get you, and without mixing too many metaphors, it's like car technology, right? Like think of like a car way back in the long ago that had, I don't know, like a carburetor, like this very elegant, very beautiful system, but beyond a certain point, it just couldn't do anymore. There's only so much you could do with this very elegant, very simple series of pipes and hoses. Super easy to follow. You just really just run your finger through it and you knew exactly where you were. But at some point you're like, well, if we really want to get this thing to be, you know, very nice, extensible, that we want to be able to produce 1 million cars, something has to change. And then you introduce like fuel injection and computers and all kinds of things, right? So we're definitely at the very elegant, hopefully we'll get there through many more streams, get to the very elegant and simple, but also kind of limited world of these basic design patterns. And then we leave it to Smudge to make the F1 Indy car that races on the track. We're content in our, you know, 2,000-pound 1950s, you know, Chevy. All right. 10 minutes left. Okay, let's see what we can do. So, but it's also a good point. It's hard actually to code with like this forced limited knowledge, but it's a great exercise. All right, so instead of our load player state, we go ahead and set the game state type is equal to load player. This is kind of true and kind of not. It's actually a problem that we won't know how to solve until we get to our chain of responsibility. Because what we actually want to do is have something that sets the next state, right? That sets the anticipatory state. and by meaning anticipates to it, is that if you've got a chain of responsibility that say, okay, once the player has successfully logged in, now we're in the load player state, right? So we're doing it kind of like in line right now, which is fine. But as we'll see next week, there's better ways to do it. All right. So inside of this guy, we're gonna fix this. We're gonna do a public expression. Did I explain that? I think I started to. And I chose not to. So, I'm not jumping around too much. I had really chastised the example for putting this much logic inside of the setter, right? And I kind of gently poked at the fact that it had a backing field to its property. We're going to do the same thing, but I was saying that you want to be really careful about how much logic you stuff into that setter. But we want to give it a private set, right? Or just no set at all. And then we want the get to return the interpreter. Right? And so that might change, but right now, this is as much as we really want to do, or need to do. And then inside of the load player state, I'm then free to call the interpreter, that interpret, and then pass in the game and pass in the context. So, lots of stuff to improve upon, lots of stuff to expand on, but this gives us the basic framework for what we need to do. We've got our game state abstract class. We are implementing it inside of our load player state, and we're taking advantage of some fun things. We're passing in a default value into our base constructor, and then instead of our interpret, we're doing just a little bit of logic, right? We're setting the context game state, and we are calling interpret on the interpreter. So not a lot of code to get us hung up on. That's really one of the benefits of this, at least for right now, is that everything's very clear. There's not a lot of glue. Okay. So, since we only have 8 minutes left, let's go ahead and just start talking about what that actually buys us. What does that get us? Okay. So, inside of my program, where I've got all of this, right? In theory, this goes away because I already know it's a player interpreter. And do I need to call interpret on the interpreter? Because the interpreter is now inside of my game state, so this goes away. So come back over to program. So this now fails. Now in order to get to that interpreter, what I typically have to do is I now have to do game state dot interpreter. Oops, we need to correct one more thing over in iGuy context. Oh. Nope, that was good. Sorry, I thought I saw something that was a little wonky. I guess not. Good. Okay. So this is already getting kind of weird, right? Game state, interpreter, interpret. This is where our facade pattern is going to help us out. Because what we really want to do with the context is present kind of like this very clean API. We don't have to go game state, interpreter, interpret, and have to see that every time. We really just want to be able to see interpret. We're going to leave it alone for right now because there's a good chance we change what that's called to something more polymorphic, like process or execute or I don't even know what. Okay. All right, so so we're interpreting. That didn't really bias a whole lot. I mean, it did, but it didn't, right? So when we get down here, we know what state we're in. But, and let's get rid of this guy. Oh, let's make one interpreter for game selection state. And then we do game state. And we're going to go ahead and inherit these things. And again, I'm using resharper to kind of shortcut this. And I want to get rid of that default there and say that the interpreter I want to use is going to be a new game selection interpreter. And then I'm going to say that for the context dot game state type is equal to game selection, and then I want to call interpreter dot interpret context. Right. So, a few points. Let's see if we can get through this pretty quickly. So, I'm calling game state interpreter interpret directly. And the question is, why am I even allowed to do that? Right? So, if I come into my game context, do I, as from the standpoint of an API, before we even get to the facade pattern, do I want this to be public? Does not seem so. Right? It could be public, but you don't really, by making it public, you end up saying, I don't really know what method I'm calling. Let's just do this. So we make this private. Oops, sorry. Boom, 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 boom. Protected, maybe? Was that going to help us? No, because our iGame context is going to get mad. But real quick, sorry, running out of time, so I'm trying to throw this in there super fast. Void interprets. Hold on, we're getting there. Alright, so now I've got this cleaner method to call, but the thing I need to fix, if I can get my head screwed on right and think it through for a second, is when I go to game state, I don't actually want to have access to interpreter. What I want is, I want interpreter to only be available to the implementing class of game state. Let's make the guy protected. And now interpreter goes away. So I changed the public keyword to protected. Oh. And Stuart makes a great point in chat. Properties defined on an interface must have the same scoping as the interface. Example given, public. Yeah, so exactly. Brain fart. Needed to make the change on my game state for interpret to be protected This allows me to continue with interpret being abstract, and so that's going to be implemented by my load player state that overrides interpret, and then it has freedom to call interpreter. But when I get down to my game context, I don't see that. All I see is the interpret method, which is being exposed by my game state. A lot of words. A lot of words. I'm running out of time, so I hope I got that out there clearly. But this is kind of the beginnings of what we want to see from an API, right? We want our context to handle all the lifting. And then when we get back over here, all I need to do is take in the user input, call interpret, and then output some code, right? So a lot of the decision making that I was doing before goes away, in the sense that I don't have to do new game selection interpreter. I don't have to pass in the context seemingly to itself. That's weird, right? I've got a nicer way to interact with my game context. However, the problem that I can't solve right now, that I won't be able to solve inside my chain of responsibility, is how do I actually switch the state? Right? How do I actually put in a command, have it be interpreted or processed, whatever, and then presumably go to the next part of my application, or return an error, right? This whole flow logic is something that I can't do right now without it being, kind of messy. So, next week, I'm going to go over the chain of responsibility pattern, and for right now, I am going to clean this up so it works, so that if Stu and Smudge want to go in there and rip the guts out of it, they can. But the issue we run into is that even though we're able to clean some stuff up, we're still left with the issue that we can't intelligently have the system automatically go to the next step. And that's something the chain of responsibility is going to help us with. And we can demonstrate that because, so we have the problem well in hand. So this is cleaner, right? We're getting to that refactor point where everything looks similar still, but we've introduced the problem of how do we actually change the interpreter, right? That's the question. Because once we have that question answered as far as how do we change the interpreter, we can have most of this stuff go away, and we can add in just a loop that gives us an exit command. We can just say, hey, just start the game, and as input comes in, the engine will decide if it should advance to the next state. We'll be able to decide what state, see what state it's actually in, and all of this will get reduced down to like 3 lines of code. And that'll be the real benefit if we come back over to our first semester. So once we've gone through the factory pattern, the interpreter pattern, the context object, now the state pattern, when we apply all of that architecture to the chain of responsibility, we'll see that we've created an architecture with not a whole lot of code that is actually really intelligent. All right. So that's it for this week. I want to thank everybody for hanging out. I'm going to catch up in chat for just a second. Make sure I'm not missing anything I want to respond to. Smudge asked when I'm going to start contributing to clean living. I'm trying to carve my time up and get more just efficient. I'm actually learning a lot from just the way that Smudge and Stu go about organizing projects, the personal software process. If you haven't seen the advanced stream or just any of Smudge and Stu going through it, you can see the difference in terms of a really refined personal software process and then what it allows you to accomplish in a very short period of time. It's in terms of like your growth as a developer, and I like to think that when I'm at work I got something similar. Not in this stream obviously because it's very basic, but the ability to take a lot of procedural steps for writing really good code and crunching it down into this very dense personal system is awesome, right? So, that's my long-winded excuse for not contributing to clean living because I have poor time management skills. But I'm getting there. I'm getting there. What am I doing? Alright, so this is still going to run, but every time we call interpret now, it's going to be calling the same interpreter because we don't have a way to intelligently switch. That's what, and again, repeating myself now, but that's what the chain responsibility pattern next week is going to give us. Come over here, make sure it builds. It does. I'm going to commit. Check my untracked files. Add those guys. I'm talking through it because the last thing I need is a reprimand from the camps of Stu and Smudge. All right, and then I'm going to sync. Looking good. Come back over here and just double check. All right, 11 seconds ago. Looking good. I want to thank everybody for hanging out. I'm gonna hop back in the chat and just kind of catch up with people. But I'll see everybody else next week. And thanks for tuning in.